Good evening, all of you. Welcome once again on the fourth day of this 7 days workshop on multivariate data analysis using SPSS. I again welcome Professor Dr. Hitesh Parmar sir uh, on today's session on cluster analysis. And before starting the session, if anybody has any query regarding the workshop or regarding yesterday's session, they can ask. Yes, Hitesh sir.
Okay, sir. So let us start. I am just sharing my screen.
Okay, sir.
Sir, just kindly
allow me. Yeah, just a minute, sir. Just a minute.
Okay, sir.
Yes, sir. Now you can share.
Okay, sir. So we will be starting from where we left yesterday. So participants, kindly just open the Word file that I have shared. I have shared the Word file, factor analysis statements. So you please open the Word file, factor analysis statements. We'll understand first of all what the data set is all about, and then we will start the factor analysis on SPSS. Once we will finish this, then we'll start cluster analysis. So this data set contains 23 statements measured on 5-point scale. These statements are related to statistics, some of them are related to maths, some of them are related to computers. At the end of this exercise, we don't know exactly how many factors or dimensions are present. Whether these statements are 23, there are different dimensions are there, or they can be clubbed into some meaningful factor, that we don't know. So what we are doing, we are exploring the things. And if some meaningful factors will be extracted, then what could be the probable relationship among them, among the variables? That also we don't know. So at the end of this exercise, we will came to know that whether there are 23 separate dimensions are there, or they can be clubbed into some meaningful factors. That is number one. Number two, what could be the relationship among the variable? And number three could be, if multiple factors are present, then which factor is most important and which factor is least important? Which variable contribute more in factor, which variable contribute less in the factor? What could be the percentage of variance explained? These answers we will get after we will conduct exploratory factor analysis. So this data entry is present in the SPSS file that has been shared with you. The name of the file is factor_HP. So you kindly open this file, factor_HP. So there are 23 columns, around 101 respondents are present, and then this data set has been created for around 100 respondents. So there are 23 variables, so you can observe 23 columns and around 100 rows. So are you ready with your file? If all are ready with the file, then we can start the session. Trupti madam, yes, the file is being shared with everyone. So as the majority of the participants are ready with the file, we can start now. Trupti madam, you just share your email ID with Ravi sir. Ravi sir will share the file with you immediately.
I have sent to each and every participant. Even I have sent the message to the group also. Trupti ma'am, please send me a message. I will just send you. Abhi, I am sending my mail ID on the chat box. Okay, ma'am, I am sending you. I am sending you. Just check your mail after 2 minutes.
There is a query set. Ujjwal set. Sir, in my case, data set are labeled. So you just click here, this one, and then it will come as numbers.
Sumi ma'am, you have received all the files and you have replied me okay, thanks also on date on 20th November 5:47 p.m. So please check your mail ID, ma'am.
Maybe you can check your spam also, sir. If maybe it is in spam, but if you have received, just open the file. So now I hope everybody is ready with the file. So we can start the session. Trupti ma'am, please check your mail. A mail has been sent to you. You just check your mail. So to run the exploratory factor analysis, we need to click on Analyze, Data Reduction. If higher versions are present with you, then it will be Dimension Reduction. So Analyze, Dimension Reduction or Data Reduction, and then Factor. We need to click on Analyze, then Data Reduction or Dimension Reduction and Factor. Once you will click on Factor, this dialog box will appear. What you need to do, you need to transfer all 23 variables into variable list. Transfer all variables into variable list. Then click on descriptives. Click on descriptives. Once you will click on descriptives, this dialog box will appear. Initial solution, it is a by default tick mark. we need to give a tick mark on KMO and Bartlett's test of sphericity. So just click on KMO and Bartlett's test of sphericity and then continue. Then click on extraction. On extraction, by default method is principal components method, so it is visible. Display, in display we require two tick marks, unrotated factor solution and scree plot. Unrotated factor solution is a by default tick mark, you need to give a tick mark to scree plot. Which method we will utilize? So we will utilize a method eigenvalues over 1. Ujjwal Seth. Yes sir, Ujjwal sir, you have a question, please ask. Ujjwal sir, please ask your question. Okay, you are muted. Okay. I am not able to unmute you.
Hello, sir.
Okay, fine.
Hello,
Yeah,
sir.
please, sir, please.
Yes, sir. There are two options: correlation and covariance. So, in this case, which one should we choose? Correlation or covariance?
By default correlation, we need not to change it.
Yes, but if covariance, if we choose covariance, then is there will be any change in this result?
There is a slight difference between covariance matrix and correlation matrix. Correlation is a standardized matrix, where covariance is the absolute one, right? When we divide the covariance with standard deviations of x values and y values, it becomes correlation and interpretation becomes easy, and we can also compare the two correlations. Covariances cannot be compared, but correlations can be compared.
Okay, sir. Thank you, sir.
Right. So correlation is a better matrix as compared to covariances, because we are fixing the range between -1 to +1 by just dividing it with standard deviations of x and y. That is the reason.
Thank you, sir.
The file that you need to open is factor_HP. Okay. You just click on continue. Click on rotation. Once you will click on rotation, this will emerge. So in rotation, we'll select Varimax rotation, then click on rotated solution and continue. Varimax and rotated solutions, and then continue. Click on scores. Click on scores. Once you will click on scores, give a tick mark to save as variables. By default method is regression, that we will not change, and continue. Click on options. In options, once you will click, you need to give a tick mark to sorted by size and suppress absolute values less than, by default is 0.1, change it to 0.5. What we are doing, we are giving command to SPSS that below 0.5 of the factor loading will not be displayed. This is what we are giving. And continue. And okay. Those who are joining late, I am again repeating the procedure. the file name that you need to open is factor_HP. What we are discussing exploratory factor analysis. You need to click on analyze, then dimension reduction and factor. Once you will click there, this dialog box will appear. You need to transfer all 23 variables into variable list. Then you need to click on descriptives, initial solution and KMO and Bartlett's test, and continue. Click on extraction. By default method is principal component method of extraction. By default tick mark is unrotated. Also give a tick mark to scree plot. Method will be eigenvalues greater than 1. Continue. Click on rotation, Varimax rotation, display rotated solution, and continue. Click on scores. Give a tick mark to save as variable. By default method is regression. Click on continue. Click on options. In option, give a tick mark to sorted by size and suppress absolute values less than 0.5. And continue and OK. So you will get your output of factor analysis. So let us understand the output. First of all, what we need to observe is KMO and Bartlett test. The thing that we need to understand is that whether the data set is suitable to run the factor analysis or not. So these two tests will tell us whether the data set are suitable to run the factor analysis or not. Now, who will give the interpretation of KMO and Bartlett? Yesterday, we have already discussed this. So who will give the interpretation? Anyone? Volunteer? Bartlett's test. Can anybody tell me null hypothesis? Ravi sir, these participants are not able to unmute themselves.
Yes, sir. What happened?
Participants are not able to unmute themselves.
No, sir. I have already allowed them. They can unmute themselves.
Okay.
I have allowed them.
Okay, sir. Okay. All participants, you can unmute yourself. The p-value is less than 0.05. It is 0.000, so it is less than 0.05. So null hypothesis can be rejected at 5% level of significance. And what was our null hypothesis? Our null hypothesis is that the intercorrelation matrix is an identity matrix. So it is rejected. So it can be concluded that the intercorrelation matrix is not an identity matrix. Second thing is KMO. So the KMO value is 0.801. In fact, it is greater than 0.7. So if factor analysis will be conducted, then fair amount of variance can be explained. So we can proceed further. These two tests are suggesting that the data are suitable to run the factor analysis. If you have any query with respect to KMO and Bartlett's test, you can just ask. The next table that we need to interpret is communality. We have already discussed communality yesterday. Thumb rule is that at least we require a 0.5 of communality. Lesser the communality, it means that variable is not sharing with anyone. Higher the communality, it means that variable is sharing higher amount of variance with the other variables. The maximum communality will be 1. So we can observe that in none of the cases the communality is less than 0.5. So it can be understood that none of the variables should be removed. There is a question that can KMO more than 0.6, can we proceed? Yes, you can proceed. Greater than 0.6, you can proceed.
Sir, what is the
So, what is the
ideal value for KMO to proceed for the
yesterday I have displayed the table. Below 0.5, don't factor.
okay, sir.
Right.
Thank
So
you, sir.
below 0.5, we will not give the factor analysis solutions.
Okay.
From 0.5 to 0.6, you can just observe the percentage variance and rotated component matrix. If it is suitable, you can report. Greater than 0.6, you can report.
Okay. Thank you, sir.
The next table that we need to interpret is total variance explained. So now you can just observe that eigenvalues, it is 7.13, 4.50, 2.10, 1.112, 0.97. So from the fourth number, the eigenvalue it is 1.112, and then it is less than 1. Our criteria of eigenvalue greater than 1 will it is suggesting that 4 number of factors can be extracted, and these 4 factors are explaining 64.63% of the variances. So this 64.63% is because of common factor, and remaining portion is unexplained. So unexplained portion is because of error of measurement factor and specific factor. So 100 minus 64, so around 34% is unexplained, and 64% it is because of the common factors. So these 4 factors are present that can be interpreted. But which are these 4 factors? Which variables are representing the factor in which manner? That we need to see. So for that, we need to see the next table. Okay, but before we proceed to next table, there is a scree plot. So another criteria, second criteria for getting the number of factors is scree plot. Now, if you closely examine the scree plot, then there is a straight line up to factor number 3, component number 3. Then there is slight deviation, and then a much more deviation can be observed. So if you consider scree plot, then it can be 3 factor, or if you consider this slight deviation into account, then we can have 4 number of factors. So if you follow the scree plot, or maybe eigenvalue greater than 1, it is suggesting 4 number of factor. Here you may consider 3 or 4 number of factor depending upon your choice. Now 2 component matrix we need to compare. The upper one is the unrotated one, and the lower one is the rotated one. The upper one is unrotated and lower one is rotated. So can anybody tell me which one is better, rotated or unrotated, and why?
So in the rotated one, the cross loading is not there among the variables.
No, we have given a criteria of 0.5. Actually, the factor loadings all are present. But why we are not able to see these values? Because we have given a cutoff criteria. This is the reason. Any other one? Which one should we take into account? Either unrotated or rotated? What do you think?
The rotated one, probably.
Rotated one, but why?
So because in the normal component matrix, there are just 3 factors which are being identified. In the rotated one, there are 4 factors that are identified. So probably it is more accurate
Yeah.
matrix.
In the last factor, there is no representation, I think, in
Yes, sir.
unrotated one.
Yes.
Right, it is blank.
Yes, sir.
But in the rotated one, a fair amount of representation of all the factors is being observed.
Yes, sir.
So that is the reason. And
Yesterday,
in unrotated,
excuse me, sir, I'm interrupting you. Sorry. In the rotated one, you mentioned that we generally go for the varimax rotation.
yes, yes.
Can you please explain what is varimax rotation? What actually it means?
Yesterday we discussed the rotation, in which we had 2 types of rotation: orthogonal rotation and oblique rotation.
Oblique rotation. Yes, sir.
Right. So orthogonal rotation, the orthogonal rotation is given in such a way that the axis remains 90° apart.
Yes, sir.
So this is the orthogonal rotation. Oblique rotation is that in which the axis do not remain 90° apart.
Yes,
So
sir.
these are the 2 options available with us, whether we wish to go with orthogonal rotation or oblique rotation. Within orthogonal rotation, we have so many options. So one of the option is varimax rotation. So we have preferred orthogonal type of rotation, and in which we have preferred varimax rotation.
Varimax rotation. Yes, sir.
Right.
Thank you, sir.
Now, in unrotated one, you can observe that majority of the variables are loaded on only and only first factor. But with respect to rotated one, it is better as compared to unrotated, because a fair amount of representation for variables is present. So for interpretation purpose, we will take rotated component matrix. So these are the variables that are representing our factor number 1. Can you suggest some good name for our factor number 1? We need to give the name of the factor. So can you suggest any name of the factor?
The perceived difficulty.
Perceived difficulties, okay. Lack of skills, okay. Mohammad Khan sir, but which kind of skill do you think that it is that?
System skills.
Related to system skills, yeah.
SPSS failure.
SPSS?
Failure.
Failure, okay, okay. Somebody has raised their hand. Please ask the question.
Sir, why there's all the numbers in one factor? Why there's no number in 2, 3, and 4?
Actually, we have given sorted by size, number 1, and number 2, subtracted suppress coefficient less than 0.5. If you remember here,
Yes, yes, sir.
if I go back here in options, we have given a here suppress absolute values less than 0.5. So less than
Okay,
0.5 values will not be displayed to us. If we'll take by default value of 0.10, then there will be all these values. And then we, in whichever case the higher values are there, we will take that value as interpretation.
Okay, sir. Thank you.
Sir, hello.
Ujjwal sir, please.
Sir, my case, the results are different from that of you.
Maybe
The
slight
results which are
deviations can be observed. This is the older one file, maybe some 1 or 2 respondent may be changed. Slight deviations can be observed.
I have three eigenvalues.
You
I
have
have 3 eigenvalues greater than 1. I have
three number of factors. 3 factors.
Yes, I have 3 factors and 3 eigenvalues greater than 1. But in your case, you have got 4 factors.
I think everybody got four factors.
But sir, I have got 3 factors only. So first one is 4.578. Second one is 3.464, and third one is 1.006, and fourth
did
is
you change?
0.874.
Just a minute. Did you change anything from this
No.
method?
No, sir.
You may again try this.
Okay.
In extraction method, you need to select principal component method and eigenvalue greater than 1 by default.
Okay, sir. Maybe there are some problem. Okay, sir.
Right. Otherwise, everybody will have 3 factors. Sorry, 4 factors.
4 factors.
You may observe some of the slight deviations in the factor loadings. Otherwise, the number of factor will remain 4.
Sir, is there any limit for the number of factors?
Number of factors can be minimum will be 1 factor and maximum will be as many number of variable as many factors.
Okay.
Right. If your intercorrelation matrix is an identity matrix, it will give you as many number of variable as factors.
Okay, sir. Thank you.
Right. And if the solution is unidimensional, then it will give you only 1 factor solution. So we will interpret rotated component matrix, and I have given a name as fear of computers. Similarly, for the second one, do you observe the negative sign, negative factor loading for the second factor?
Yes, sir.
Yes, sir.
So why it is so?
Sir, while coding, it must is when we have selected option while coding. Hello.
Please. While coding.
While coding, when we opted for the option, it must be say if yes or no. It is just reverse. If we change that, it will be rectified.
Yes. So while coding, we need to give rectification. It is a 5-point scale. So ideally, this statement should be reverse coded. Why? Because it is a positive statement. Standard deviations excite me. It's a positive statement. And if you examine the other statements, then they are the negative statements related to fear of everything. Right. So ideally, what should we do? The respondent who has given 1 should be coded as 5, 2 should be coded at 4, 3 will remain 3, 4 should become 2, and 5 should become 1. Is it clear, everybody? this statement should be reversely coded. So the coding should be done in like this. Okay.
Sir, one point more, once again I want to ask.
Yeah, please.
In scree plot, you are showing eigenvalue more than one.
Yes.
Whereas
Yeah.
in component matrix, it is there are many other figures. So when we have suppressed we have selected 0.5.
Yeah, please.
We have not accepted below 0.5, but there are values which are above 0.5. They are not featured there.
These are the eigenvalues.
Yeah, eigenvalue one actually. Achha,
So
these
this
are
is
more than one.
Yes, more than one. So you can observe here.
Okay.
Here in the y-axis, you can observe the eigenvalues. So here you can cumulatively observe here.
There are other values also which are more than one, apart from 4.
No.
So, but in this the second slide, the last slide which you have shown, it was the values are more than 0.5.
More than 0.5 is for factor loading, not for the eigenvalues.
Okay.
What we have given a cutoff
Right.
criteria for factor loadings. So these are the factor loading, not the eigenvalues.
Okay.
Right. Yeah, somebody also raised the hand.
So can you please explain this negative sign in the second component?
Yeah, that is what we are discussing. The statement was positively framed. So ideally, it should be reversely coded. Right, 1 should become 5 and like this. Mansi ma'am, please ask your question.
Sir, actually, I want to know if the rotation, is there any criteria for choosing a particular rotation, or I can use a hit and trial method?
No. Generally, the orthogonal rotation and oblique rotation. So in orthogonal rotation, these axes remain 90° apart. So what does it mean when we have 90° apart? There is a complete independence. So if you feel that the factors are independent of each other, or as you wish to utilize them into in subsequent analysis as independent variables, then you should give orthogonal rotation. If you think that they are not independent, then you should have oblique rotation. So this should be your criteria in your mind.
Okay, sir. Thank you, sir.
So when we have taken separate questions, means in a questionnaire, that means
Yes.
we have assumed that these are separate variables.
Dimensions.
Yeah.
Yes.
So we have to go for a rotated matrix only.
Rotated is always present. We need to compare unrotated with rotated, and whichever is better, we will go with that matrix. Right. Actually, initially we should not give the rotation. First of all, unrotated matrix we should see. If we are not satisfied with the unrotated one, we should give rotation. And why rotation should be given, that we already discussed yesterday. Right? When the factors are, the variables are fairly parallel with both factors. For example, yesterday we took the example. So the interpretation becomes ambiguous that this variable should be considered as a part of which factor. So we are giving rotation, and rotation makes it very clear. Now the name of the factor that has been given, as I have given, fear of statistics. Third factor I have given a name as peer evaluation. And fourth factor I give a name as fear of mathematics. Is it clear, everybody? The name of the factor in this way you can give.
Yes, sir.
Okay. And then you can observe the factor scores. So factor scores it is available at your in the data entry itself. You just click on the data view of your SPSS file, and then these factor scores you can observe.
Excuse me, sir.
Yes, please.
If we have one item which is like having a negative factor loading in one factor and a positive but a less factor loading in another factor, where should we consider it? Should we, change the coding, or we can consider it in the positive one?
If the item is reversely coded, if it is, say for example, standard deviations excite me in our case, right? So say for example, it is showing some negative value. So ideally, what should we do? First of all, we need to reversely code these, and then we should see the results.
Okay, wherever is the higher factor loading, we'll consider that.
Yeah.
Okay,
Yeah.
thank you.
So these factor scores you can utilize in your subsequent analysis. Now you do not have any 23 separate dimensions. You have 4 different dimensions. So first one is fear of computer, second one is fear of statistics, third one is peer evaluation, fourth one is fear of computers, or exactly I do not remember. The fourth one is fear of mathematics, right? So these 4 factors you can utilize in your subsequent analysis. These are the individual variables score, but these are the standardized score.
So how we are getting this?
How?
Means what procedure we have used for this? We have got.
We have given a save as variable. If you remember, we have given a tick mark to save as variable.
Okay.
Right. So if you have given a tick mark to save as variable, so the factor scores are being saved here.
Correct.
Right. Now you can use these factor scores. Say for example, your next research question is with respect to gender, whether the fear of mathematics, fear of statistics, fear of computer, it is same or different. So if these scores are normally distributed, you can perform independent sample t-test. If it is not normally distributed, you can perform Mann-Whitney U-test. Okay. Suppose age, with respect to age category, you wish to analyze these fears, then you may perform either ANOVA or you can perform Kruskal-Wallis test. These 4 variables are independent variables. Suppose you have already available variable with you, that is the dependent variable. So you may run a regression analysis by considering these 4 variables as independent variables.
So please repeat once again because it was too fast for me.
Okay. Say for example, we have a variable called gender available with us. So we have 2 categories, male respondent and female respondent.
Correct.
Now our next research question is whether with respect to both the categories, whether the fear is same or different.
Correct.
Right. So what we can do, we can run independent sample t-test, or if these scores are not normally distributed, then you may switch to non-parametric equivalence of independent sample t-test, that is known as Mann-Whitney U-test. Okay. Is it clear? Okay. Now say for example, we have another variable called age of the respondent, in which we have 3 to 4 categories of age: 18 to 25, 26 to 35, 36 to 45. In this way, more than 2 groups we have, say for example. Then our again a question is whether with respect to age, groups of the age, whether these types of fear are same or different. So again you may run ANOVA, one-way analysis of variance, or you may run Kruskal-Wallis test, which is the non-parametric equivalent test of one-way analysis of variance. Now say for example, I hope up to this it is clear.
Sir, if the initial data is parametric,
then
also we have to see for a non-parametric option.
The data is parametric, but we need to check the assumptions of parametric test. And one of the assumption of parametric test is data are normally distributed. Right. So we need to check it.
Correct. Correct.
Right. That is the reason.
Hello, sir.
Now, yes, Ujjwal said so.
Sir, what does this factor scores means? I mean, first variable factor score is 0.43633. I can see from the figure. What does this mean? Is it
you are not clearly audible. For which slide you are talking?
Sir, what does this factor score mean actually?
These factor scores are the standardized values. If you calculate mean of this column, it will be 0. If you remember, yesterday we discussed a standardized. So these values are the standardized, which here will have on an average mean of 0 and standard deviation of +1 to -1.
So how this score are obtained from?
There are so many methods in which you can obtain the score. So the method that you have selected is the regression method. If you change the method, the score will change. But these are the standardized scores. If you wish to have unstandardized score, then the method is slightly different. It is you can have in your Excel sheet or SPSS also you can calculate. How you can calculate? Say for example,
what we are regressing, what variables we are regressing here?
That is what I am explaining. Say for example, you are calculating a factor score for fear of mathematics, for example. So fear of mathematics, you are aware from rotated component matrix that these 3 variables represent fear of mathematics. So what you can do, you can just combine the scores of fear, these 3 statements. So you have your data entry in your SPSS. So you just combine these scores. So this variable number 1 plus variable number 2 plus variable number 3 and divided by 3. That will be the average score of these 3. This average score you will get in a single column, and this is nothing but your factor score. Are you getting my point?
Yes, sir. Yes,
if
sir.
you wish to have unstandardized one, then in this way you can have. So this is nothing but it is the yesterday we discussed F1 is equal to W1 x1 plus W2 x2 plus W3 x3. So in this way you can find the scores of factors.
Yes.
Then after finding it, SPSS is making this score as standardized one. So it is making as a mean of 0 and standard deviation of +or -1.
So sir, these are weights. 0.723 are weights. 0.652 are is weight. So these are weights.
No, these are not weights. After getting the row score, it is being converted into the standardized one.
Yes.
So it is just you can compare with Z score if you are aware with Z score.
Yes.
So it is just like the Z scores.
Okay, sir.
Excuse me, sir.
Yes.
Sir, the earlier you mentioned that all the factor loadings which are less than 0.5, we will exclude them from our analysis. Here, if we are getting, say, in the factor
loading,
1.
Factor loading less than 0.5, we have given not visible.
Okay, it will not
these are
consider
not
at
factor
all.
loading. These are not factor loading. 0.43, these are not factor loading.
These are the
these are the standardized values.
Okay, sir. Okay.
Right. These are not factor loadings.
Okay. These are the standardized values. Okay.
Yes.
Okay, sir. Okay. Thank you, sir.
So should we conclude this session of factor analysis? Yeah, please.
So on which scale can we treat the standardized values? Is it compulsory to treat them as a scalar data?
It is scale data.
Okay.
It is scale data.
Sir, excuse me, sir.
Yes,
So
please.
we say with us that is Bartlett scores. What is the difference between saving us regression scores as well as saving us Bartlett?
It is another option available. There are so many methods available, right? One of the method I explain you that you just calculate average score and then you can find the average values.
Yes.
So, so many researchers have given so many methods. So, whichever method you will select, the score will be a slightly different.
So for if we say with us Bartlett scores, in which other further in which analysis can we use that?
This score you can utilize in your t-test, ANOVA, regression, all types of analysis.
Okay, so if you say it as a Bartlett scores also, doesn't make any difference?
The score will be different.
Okay.
The score, the method, if you change the method, the entire analysis will change.
But the same scores can be used further for all the other analyses.
Yes, yes, yes.
Okay, sir.
So if you permit, then we close the session of exploratory factor analysis, and then we can start the cluster analysis.
Yes, sir.
So just one final question.
Yes, yes, please.
Sir, by doing this exercise, what lastly we are going to conclude, means what we are going to interpret out of this?
Yes, we are going to interpret that they are not 23 separate dimensions, but they can be clubbed into 4 meaningful factors. Factor number 1 is fear of whatever, factor number 2, factor number 3, factor number 4. Then factor number 1 is most important factor because their percentage explanation is highest. Then lesser in importance in accordance to factor number 2, factor number 3, and factor number 4. Within a factor number 1, you can just observe the factor loadings. So in whichever case the factor loading is higher, the variable is contributing more. And then this variable will be considered as that part of factor. So say for example, if we see the first factor, so the most important variable which is contributing highest is SPSS always crashes when I try to use it in factor number 1. So in this way, and then your decision making becomes simple. You need not to deal with 23 separately variables, but whatever analysis you want to perform, you can perform with only 4 factors. You have your factor score with you, and you can just proceed with that. So it is a time consuming, it will take lesser time, and your decision making becomes also very simple, because what you are doing, you are dealing with only now 4 factors and not the 23 separate variables.
Sir, I did it with instead of 44 variables, I clubbed my data into 4 variables. And later on,
Yes.
I could find out the KMO value was better when I put it as an individual variable. I mean, instead of putting 4 variables, when I calculated for 44, it was KMO was better.
Can you please repeat? You run the factor analysis with 44 variables.
So I initially I did it. In fact, I clubbed all the 44 depending on the nature of the questionnaire. I clubbed into 4 variables. What we have calculated as factor 1, factor 2, factor 3, factor 4. I assumed that there could be prevalence factor, there could be trigger factor like this. I found 4 factors and kept the questions under that. Okay. And I calculated for just for sake of means for easy calculation. If whatever the assumption, I can see through the questionnaire if it is correct or not. So I did that exercise, and then I did it in independent variables, all the 44 differently.
Okay.
So in my case, the KMO value is better than
it will be mixed, but the way you have separated, it will not come in that way. It will be mixed.
it will mix basically.
Right. The
There
rotated
is
component
overlapping
matrix
in
you
the-
will get is the mixture of variables.
Okay, sir. That means the
Right.
clubbing which I
So-
did was not correct. And
yes, it is not
there is
correct.
some
Based on
overlapping.
the pattern of relationship, it is suggesting something different.
Right. There is overlapping in between factor 1, 2, 3, 4.
Yes. Yes. It will happen.
Okay.
Always it will happen.
Right, sir. Right. Okay.
Ujjwal said, sir, he is saying that an example should clear the idea of factor score better, but we do not have time to give you the example. You can have on your own, you can just add the gender or age into this data set, and then you may run a t-test or ANOVA. If univariate analysis is clear to you, it should be clear at this moment of time.
Sir,
Right.
is it a good, excuse me, sir?
Yes,
Sir,
please. Yes.
is it a good practice to replace missing values with mean, or should I remove those cases which have missing values?
If you have few missing values, then keep it as it is, or maybe one or two if you have one or two missing value. But if you observe a higher number of missing values, more than 2% or 5%, then you should replace it with mean.
Alright. Sir, then I should do it during factor analysis only, or
Yes.
should I do it?
Yes. Yes. Ideally, you
Because there
should
is an
do
option.
when you are performing factor analysis.
Thank you, sir.
And sir, when we are going to take up this Bartlett test instead of regression, if we have chosen a regression
This is
method.
the another option available to you.
Okay.
There is nothing like that. This method is more suitable as compared to this one. But
okay.
This one more option is available to you.
Correct.
Okay. So we are closing factor analysis and we are starting cluster analysis. If in factor score, if it is not clear, you may try on your own with whatever explanation I have given. If you have any query, then you can mail me or you can phone me, and then we will sort it out. Right? What you need to do, you need to just utilize the factor scores with other variables. Just consider these factor score as variables, and then you can proceed further. Now, in cluster analysis, this method is one of the most utilized method in multivariate analysis. Factor analysis is also widely used. Cluster analysis is also widely used. So one of the most basic abilities of living creatures involves the grouping of similar objects to produce a classification. So it's a classification technique in which we group similar objects. So the basic difference between the factor and cluster is that in factor analysis, we were clubbing the variables. In cluster analysis, what we are doing, we are clubbing or grouping our respondents. This is the basic difference between cluster analysis and factor analysis. Is it clear? What exactly we are doing in cluster analysis? We are grouping or clubbing our respondents.
Yes.
In a factor analysis, we clubbed our variables. Now we are clubbing our respondents. So classification scheme may simply represent a convenient method for organizing a large data set so that it can be understood more easily and information retrieved more efficiently. Purpose of the cluster analysis is to discover a system of organizing observations, usually people or maybe product, into certain groups, where members of the groups share properties in common. So whatever the number of respondents share common properties, they will be clubbed into a group. So cluster analysis is a group of multivariate technique whose primary purpose is to group objects or people or our respondents based on the characteristics they possess. So here you can observe the three clusters. So these clusters have been formed in such a way that the distance between two clusters is maximum, and within the this respondent, the distance should be minimum. So based on similarity, they can be clubbed. So finding groups of objects, respondent, or maybe product or other entities such that the objects in a group will be similar to one another and different from the objects in other groups. So in between two clusters, there will be heterogeneity, and within the cluster, you can observe homogeneity. So the intra-cluster distance are minimized. Within the cluster, their respondents will be very similar, so the distance would be minimum. And from one cluster to another cluster, the respondent would be different from each other. Their opinion would be different from each other. So inter-cluster distance are maximized. Now cluster variate. On what basis you are clustering your respondent? So this is nothing but cluster variate. So cluster variate is nothing but it's a combination of more than one variable. So it is variate. So the cluster variate is the set of variables. You may choose based on your experience that which variables you prefer to start the cluster analysis. So you need to select more than one variable. So the cluster variate is the set of variables representing the characteristics used to compare objects. On what basis you wish to compare your objects in the cluster analysis. It is the only multivariate technique that does not estimate the variate empirically, but specified by the researcher. So as a researcher, you have all freedom to select your variate. Variate means more than one variable. So on what basis you wish to compare your object, you can select that number of variable. You can select 3, 4, 5, 6, depending upon your choice. Applications. I am again repeating this point. Cluster variate. Cluster variate is nothing but on what basis you wish to run the cluster analysis. So you are grouping the objects, but on what basis you are grouping your object? So you need to identify more than one variable. So if it is more than one variable, then only it will become variate. So identify more than one variable on the basis you wish to compare your objects. And you have all your freedom. As a researcher, you have all your freedom to give, or you in this way you cannot empirically test that which variable should qualify as variates.
Pardon,
So
sir?
as a researcher, yeah, please.
What I told you when you are discussing about the earlier topic, factor analysis. Is it the same thing which I did by chance, cluster variate?
No.
Because I have grouped a few of the variables on the basis of.
No. You have not done this. What you have done, you have specified latent variable. Just what you have done, you have specified your latent variable. Right. The first latent variable is being measured by these 3, 4, 5 variables. Second latent variable is being measured by again number of variables. So what you have done, you have just specified before running the factor analysis, you have specified the number of factors and the grouping of factors also.
Correct. Got it.
Some of the applications in marketing research, dividing customers into homogeneous groups is one of the basic strategies of marketing. You all are aware. A market researcher may, for example, ask how to group consumers who seek similar benefits from a product so he or she can be communicated with them in a better way. So in this way, marketing people can utilize cluster analysis. A car manufacturer believes that buying a sports car is not solely based on one's means or one's age, but it is more a lifestyle decision. With sports car buyers having a pattern of lifestyle that is different from those who do not buy the sports car. So there are two groups, maybe their lifestyle is different, who are buying the sports car and who are not buying the sports car. So the manufacturer employs cluster analysis to try to identify people with a lifestyle most associated with buying sports cars, and then to create a focused marketing campaign. So the cluster analysis will give that these people are having more associated a lifestyle which can be, then they can be converted as a probable buyer of sports cars. So cluster analysis will clearly identify that this is the group of people. You can focus this number of people and then probably they will be converted into the sales. But how does cluster analysis work? So suppose a marketing researcher wishes to determine market segments in a community based on patterns of loyalty to brands and stores. There are two variables, patterns of loyalty to brands and loyalty to stores. A small sample of 7 respondents is selected as a pilot test of how cluster analysis can be applied. For our understanding only, for only 7 respondents, we will understand the concept of cluster analysis, how it is work, right? And for our simplicity of the understanding, we have just taken only 2 variables. These variables are loyalty, store loyalty, and brand loyalty. So the cluster variate we are selecting, this variable are store loyalty and brand loyalty. They are our cluster variate. On this basis, we will try to group our 7 respondents based on these 2 variables. These variables are measured on 10-point scale, 0 to 10-point scale. Higher the score, the better the loyalty. So let us start. So what we will get, let us say that there are 7 respondents and they can be named from A to G. So A, B, C, D, E, F, G, these are our respondents. V1 and V2 are our variables. V1 is store loyalty and V2 is brand loyalty. And these are the scores obtained from the respondents in a 10-point scale. 3, 4, 4, 2, 6, 7, 6, 2, 5, 7, 7, 7, 6. Is it clear? Now let us understand how cluster analysis works. So first of all, we need to put them into the scatter plot diagram. So scatter plot x-axis is V1 and y-axis is V2. And based on the scores, these variables, these respondents are being substituted. Say for example, for A, respondent number A, for the score of V1 it is 3 and score of V2 it is 2. So 3 and 2 is the score of A. So 3 and 2. In this way, this scatter plot matrix is being presented. Is it clear, everybody?
Yes, sir.
Okay. Now, the primary objective of cluster analysis is to define the structure of the data by placing the most similar observations into group. What we need to do? We need to just put similar object or similar respondents into the group. To accomplish this task, we must address three basic questions. So what are these three questions? How do we measure similarity? How can we say that these two people are having similar approach? So how do we measure similarity? Number one. After measuring the similarity, how do we form clusters? Whether only one cluster can be formed or as many respondents as the cluster form. How do we form the cluster? How can we separate the respondents or groups from one to another? How can we determine the heterogeneity? And how many clusters or groups do we form? So these are the three questions that we need to answer. So to understand this, first of all, this data is being converted into the distance matrix. So this is the distance matrix between the observations A to G. Is it okay? Do you understand the distance between A to B? It is 3.16. From A to C, the distance is 5.09. There are so many methods in which you can calculate the distance. Say, for example, the scores of x1, y1, x2, y2 you can take. So x2 minus x1 square plus y2 minus y1 square, and then you can take the square root. So it is one of the method to calculate the distance. If you do not calculate in a square root, so it will be the absolute one, right? So there are so many ways in which you can calculate the distance between 2 points. Again, I am going back. Can you tell me which two observations are very nearer to each other?
So E and F.
E and F, they are very nearer to each other. And which variable, which respondents are very far from each other?
A and G.
A and G, okay.
D and A.
F.
A and
D and A.
A and F.
D and F, A and D. So these respondents are very far from each other. A and F is also very far from
A and
each
F is
other. Yeah. So you can observe the distance. Yes, Bignesh ji, please ask your question. Bignesh ji, please ask your question. Sir, is the distance explain the difference? That we need to discuss. There can be two approaches. Our objective is to measure the similarity. So in whichever case we will have a similar approach, obviously they will be nearer to each other in scatter plot. And if it is this, say for example, E and F, they are nearer to each other, it means that they will have a lesser kind of distance as compared to other objects. So the distance will definitely give the answer that this E and F, these two respondent is having similar kind of approach. So they can be clubbed together. What could be the other ways to identify similarity? One of the method is distance. What could be another way to identify similarity, that whether these two objects are having similar approach or not?
Sir, if it is qualitative, then attributes.
Okay. Which statistical method will tell us that whether these two respondent are, yes, correlation analysis. Shruti madam has given an answer of correlation analysis. So second option available to measure the similarity is correlation. Distance in what sense? Distance means from this point to this point. If you wish to go, then what is the distance? So say for example, this E is having 6 as the x-axis, it is 6, and y-axis it is also 6, and from F it is x-axis is 7 and y-axis is 7. So from the point 6 6, you if you wish to go point number 7 7, then how can you go? Then you can have a triangle from 6 to 7, and then a vertical line and a horizontal line from 6 to 7, then a vertical line, and then a diagonal. And then you can either you may wish to go either horizontally and vertically, this is path number 1, or diagonally you can also go. So diagonal distance will be lesser as compared to the horizontal and vertical distance. So you can reach there. So in this way you can define the distance. Is it clear?
Yes, sir.
Karmakar sir. Now moving further, so this is our distance matrix. This is our distance matrix. So if the distance is smaller, we can say that these two respondents are very nearer to each other. If distance is larger, we can say that they are very far from each other. So you can observe this matrix. The minimum value I can observe is 1.14, and it is for E and F. So you can say that the respondent number E and F, they are very nearer to each other. The highest value that I can observe is it 6.40? Yes.
Yes, sir.
6.40. And it is for A and F. So A and F, they are having highest distance, and E and F, they are very nearer to each other. So A and F is having highest distance, E and F is nearer to each other. After E and F, what we can observe is from 1.41, if we are observing this matrix, then we can have a value of 2. But 2 we can observe for 3 pairs. In between B and C, in between C and D, and in between E and G. So between B and C, E and G, this one, and maybe in between D and C, this one, right? So distance will tell us that whether they are having similar approach or not. And second method that you can apply is correlation measure. But ideally, we should apply distance measure, not the correlation measure. Why, we will discuss in our subsequent slides. Up till now, is it clear what we are doing? We have just obtained our distance matrix.
Yes, sir.
Now moving further, the process is just like this. Identify the two most similar or closest observations not already in the same cluster and combine their clusters. So what you need to do, just identify the minimum distance and combine these two observations into a cluster. We apply this rule repeatedly to generate a number of cluster solutions, starting with each observation in its own cluster, and then combining the two clusters at a time until all observations are in a single cluster. So one by one, step by step, we will combine our observations, and at the last stage, all observations will be in a one cluster. So this process is known as hierarchical procedure because it moves in a stepwise fashion from hierarchy. From, say for example, if it is this case, then from 7 cluster to 6 cluster to 5, 4, 3, 2, 1 in that way. And this method is also agglomerative because clusters are formed by the combination of existing cluster. So once the two respondents are combined, with these two respondent, another respondent will be combined in our next step. So that is why this method is also known as agglomerative method. Now let us do this process for our data set. In the initial solution, the cluster membership, the all 7 respondent is separated. So the number of clusters are 7. Whatever number of respondent, that will become our number of cluster in the initial stage, the first stage. Then, as you are aware that E and F is having a smaller kind of the distance as compared to all other distance. So in the first step, what we will do, we will combine E and F. So A, B, C, D, that will remain as it is. E and F will become a one cluster and G is again a separate. So from 7 cluster, we moved into 6 cluster solution. Then the software will give us the overall similarity measure. So the overall similarity measure is nothing but the distance between E and F. So what is the distance between E and F? The distance between E and F is 1.41. So the overall similarity measure is 1.41. Is it clear, the first row? Why we combine E and F?
Yes, sir.
Yes, sir.
Okay. Now, if I again go back to our distance matrix, this one, with respect to E and F, now, which two observations you would like to combine in our second step? So from 1.41, we need to move to the next lesser distance. So next lesser distance, if you can observe as 2, but you have 3 choices available. You can combine B and C, you can combine C and D, you can combine E and G. So out of these 3 pair, which pair you would like to combine? The question is, can we predetermine cluster earlier? No, we cannot predetermine cluster earlier. We need to take our judgment that how many clusters do we need to form. So for that only we are calculating that average distance. And on the basis of that average distance, we'll take our decision that whether 4 number of clusters should be formed or 3 cluster form or 5 cluster form. So the number of cluster of that decision will be taken by the last column that we produced. This one, overall similarity measure, that we will understand once we will run the analysis. So you have 3 choices available with 2 distance. But which pair you would like to combine and why? G and E. Okay. G and E. Why we would like to combine G and E? Because E is common. E and F. So there is a cluster is already formed between E and F. So E is common. That is why we will select E and G. So G respondent can be clubbed with E and F. So one cluster can be formed by combining E, F, and G. So at initial solution 2, the E and G are combined. So from 6 number of cluster, we moved to 5 number of cluster. Now we have a 1 cluster of E, F, and G, and other respondents are separated. And then the overall similarity measure is increased to 2.19. This is the average distance. Then again we have a choice of 2 of C and D, and then B and C. So from 5 to 4, C and D will become a 1 cluster, and from 4 to 3, B, C, and D will become 1 cluster. Then from 3 to 2, again B, C, D, E, F, G will become 1 cluster, and from 2 to 1, all respondents are combined, and it will be 1 cluster solution. So what we have done, we moved from 7 cluster to 1 cluster. So suppose you have 200 respondent, then SPSS will start from 200 and it will end to 1 cluster. It will start from 200, whatever number of respondent, it will start, and one by one, in each stage, the respondent will be combined and the final solution will be 1 cluster solution. Now, how can you take the decision that whether 1 cluster is appropriate or 2 cluster is appropriate or 3 cluster is appropriate, or there cannot be any cluster? How can we take the decision? So for that, we need to observe this overall similarity measure. You need to observe that where the highest change is occurring. So you can start with 1 cluster solution from the base, and then you can move further. So 1 cluster solution, it is 3.42. Then from 3.42, it becomes 2.89. So from 2.89, again it is 2.23. Then 2.23, 2.14. From 2.14, 2.19, and then 1.41. So highest observations or the highest difference you can observe is from 1 to 2, it is around 0.5. Then from 2 to 3, around 0.6 kind of a thing. It is greater than 1 to 2. So from 2 to 3, you have observed a fair amount of difference. And then from 5 to 6, you have observed a fair amount of difference. So you have 2 choices available. Either you can go by 3 number of cluster, or you may go by 6 number of cluster. You have 2 choice available. Either 3 cluster is appropriate or 6 cluster is appropriate. The final decision will be taken when you will see the cluster membership. Cluster membership is just like, say for example, you have 100 respondents. Then it is suggesting that 3 number of clusters should be formed. But when you see the number of respondent, then in cluster number 1, you are observing as 70 respondent. Cluster number 2, you are observing 25 respondent, and cluster number 3, you are observing only 5 respondent. So this is not appropriate. A fair similar kind of distribution between the respondents should be observed. Then only you should go with that number of cluster. This will give you an initial idea that how many number of factors should we take, right? So you can take on this basis either 3 or 6, but when you will see the number of respondent in each cluster, then it will become clearer to you whether you wish to go by how many number of factors. Sorry, clusters. You are not audible, madam. You are not clearly audible, madam. Please repeat for average within cluster distance measurement. This is the average distance. We have started with 1.41. Right, this is the distance between E and F. You observe, then this is the E and F distance. Then you have combined one more observation, G. So the distance is becoming more and it becomes 2.19. So the overall similarity measure, it is increasing from 1.41 to 2.19. So this 2.19 is nothing but it is the average distance of this E, F and G. So distance between EF plus distance between FG plus distance between EG and divided by 3. Whatever answer you will get the answer of 2.19. So it is the average distance between EF and G. So in this way, this overall similarity is being created. Now our the decision will be on the basis of the where we are observing highest percentage difference, but also you can consider as absolute difference, because if the absolute difference is higher, the percentage difference will also be higher. So from 2 to 3 you have observed a fair amount of difference, and from 5 to 6 you have observed fair amount of difference. Actually the highest one is 6, this one 0.8 around. So on the basis of it is suggesting 6 number of cluster. So ideally you should observe the number of respondent in all these 6 number of whatever the representation. Suppose you have higher sample size, then 6 cluster can also be formed. But suppose you have 20-25 respondent, then 6 cluster cannot have a meaningful solution. So what you can do, you can have what is the second choice available. So the second choice is for 3 number of cluster. So your decision will be going for 3 number of cluster. And then again observe that what is the representation in cluster number 1, cluster number 2 and cluster number 3. Fine. So this is a dendogram. So dendogram is nothing but whatever process we have done, it is the graphical representation of this process. So you can observe number 1 here. So number 1 is E and F. So E and F, and then the distance at combination. So around 1.4, this distance you can observe. So at the first one, E and F are combined, right? At distance of 1.36 or 1.4. Then at second stage, at distance of 2, the G respondent is being combined. So the G is being combined at 2. Then at third stage, C and D are combined at a distance of 2. And at fourth stage, the B, C and D are combined. Sorry, B and C are combined. Then in the next stage, these B, C, D are combined with E, F and G. And at the final stage, A respondent is combined at distance of, I think, 3.14 or something. So this is nothing but a representation of whatever the process we have done. It is the same process. So dendrogram is also representing the same thing. Sample size. The issue of sample size in cluster analysis does not relate to any statistical inference issues. But instead, the sample size must be large enough to provide sufficient representation of small groups within the population and represent the underlying structure. It means that if two cluster solutions are suggested, then in both the cluster, a fair amount of representation should be observed. So in that way only the sample size will be meaningful. Otherwise, statistically, there are no rules that this is the minimum number of sample size to run the cluster analysis. Correlation approach is our second choice. The first option that we discuss is the distance matrix. On the basis of distance, we try to measure the similarity between the objects. The second one is the correlation approach. So the correlation approach or measure of similarity does not look at the magnitude, but at the pattern of the values, right? It is just indicating that the pattern of the values, not the magnitude. And what we are interested in cluster analysis, we are interested in the pattern, not the pattern, but the magnitude. And that is why we should not apply the correlation approach in our similarity measure. So correlation measures are rarely used because emphasis in most applications of cluster analysis is on the magnitude of the objects, not the pattern of values. So let us take one example so it will be clear. Just observe this data set. Don't think about the correlation. Just observe first of all the data set. By observing the data set, what do you think that which cases are very nearer to each other? What do you think? By observing these respondents,
First and second case is nearer to each
first
other.
and second case is nearer, yes.
Third and fourth are also
Third
near.
and fourth are also nearer.
Yes, sir. And 5, 6, 7 again they are nearer to each other.
Yes, yes, yes. So this is the pattern. Now, if we observe the correlation, so we think that 1 and 2 are very nearer to each other. Now just observe the correlation. Minus 0.14. Correlation will tell that they are far from each other. They are not similar. Their approach is not similar. But actually, on the basis of magnitude, what we are actually interested, 1 and 2 are nearer. In fact, 5 and 7 are also nearer. But if we'll see the correlation between 5 and 7, yes, it is 0.96. Okay, fine. But between 1 and 2, again, it is negative. Between, if we observe 2 and 3, again, it is 0.00. Between 1 and 4, again, it is 0.087. Between 1 and 5, these respondent are completely different. Respondent number 1 and respondent number 5, if you observe.
Yes,
but
sir.
their correlation is 0.96.
Yes, sir.
Right. So this is the reason why correlation approach should not be used while we go for similarity approach in cluster analysis. Otherwise, the technique is perfect. It has its own applications. But as a similarity measure, the distance matrix is more meaningful as compared to correlation. Okay.
Yes, sir.
So in distance also SPSS will give you so many options, so you can choose anybody. But if you select, say for example, Euclidean distance, the result will be different. If you select city block distance, the result will be different. So depending upon which method you are selecting, it will give you a different clustering solutions. So then final judgment will be yours, that whether you wish to go by which type of distance. So comparing to correlation analysis, I think it is very clear that with similarity measure, the cases 1 and 2 form one group, case 4, 5, 6, 7 from another group, and the third group is of case number 3. If we apply correlation approach, then 1, 5, 7, 2, 4, 6, and 3. So 1, 5, 7, again, if we go by this method, so 1, 5, and 7, they will become one group. So it will be misleading. So that is the reason we should not go by the correlation approach. Standardizing the data. Distance measures are quite sensitive to the different scales or magnitudes among the variables. So different scales means here our both variables we measured on a 10-point scale, right? From 0 to 10. So the scale is similar. So there is no need for standardizing the data. But if your clustering variate are measured on different types of scale, maybe one variable is measured on a 5-point, second is on a 7-point, third on a 10-point, 4 maybe in absolute numbers, values. So if different scales are being used, then you need to give a tick mark on a standardizing the data before running the analysis. There is a question, for continuous variables correlation will be appropriate, then magnitude no. In cluster analysis, always our first choice should be distance measures, right? And always prefer distance measure. This is my recommendation, that you should always prefer the distance measure as compared to correlation approach, whether the data is continuous data or it's a 5-point scale data, whatever the data are, but always prefer distance metrics. So if different types of scales you have used, then you need to give a tick mark for standardizing the data. Partitioning, you have where you can have a partition, how you are separating the clusters. So a wide range of partitioning procedures has been developed across discipline in which cluster analysis has been applied. The most widely used procedures can be classified as either it can be hierarchical or it can be non-hierarchical. What process we discussed was the hierarchical clustering. From 7 cluster to 6, 5, 4, so that was the hierarchical clustering. And within the hierarchical, you have again two options available, agglomerative and divisive. So in agglomerative, start with the points as individual cluster, that's what we did. And at each step, merge the closest pair of clusters until only one cluster left. So that is what we did in agglomerative, in hierarchical clustering, and within hierarchical clustering, agglomerative. The example that we took was the agglomerative. In division, it is the opposite of the agglomerative. So start with one cluster, all inclusive cluster. So it is the exactly opposite of that one. And at each step, split a cluster until each cluster contains a point. So at the last stage, you will have whatever number of respondent equal to number of clusters. So there can be two approach, agglomerative and division. Fine. So you just open now the SPSS file cluster. This one we have discussed. Cluster, the file name is cluster. It will take maybe around 20 minutes. I hope it is okay to everybody, right? So that in our next session we can start a new chapter. So today I want to finish the cluster analysis. Mohammad Khan sir, I hope it will be convenient to you. Around 20 minutes.
Yes, sir. Go ahead, please. Thank you.
Okay. So kindly open the file cluster. So let us understand our variables first of all. So we have age, occupation, and gender. These three variables are our demographic profile. Then product quality, website, sales force image, and competitive pricing. These are the four variables. They are measured on a 5-point scale. Okay, understood the data? These four variables from product quality to competitive pricing, they will become our clustering variate. On this basis, we will perform the cluster analysis. On these four variables, we will perform the cluster analysis. And then once we form the cluster, then we will see the profile of respondents with respect to cluster. So for that, we will utilize age, occupation, and gender. So can we start now? If you are ready with your file,
Yes, sir.
everybody, then okay, we can start now. So you need to click on Analyze, Classify, and Hierarchical Cluster. Analyze, Classify, and Hierarchical Cluster. Once you will click on Hierarchical Cluster, this type of dialog box will be appear. Just transfer all these four variables. So these four variables are our clustering variate. So these four variables are selected. Click on Statistics. Give a tick mark to agglomeration schedule and continue. Give a tick mark to agglomeration schedule and continue. Click on Plots. Give a tick mark to Dendogram and continue. Tick mark to Dendogram and continue. Click on the method. Then here the cluster method I have selected as between group linkage. There are so many methods available. You can also select wards method, but your result will depend upon your cluster method. cluster method means how you are forming the clusters. So there are so many methods SPSS is offering. Each method will give you different result. Similarly, for distance one also, you have these many options available. I have selected the Euclidean distance. I was talking about the standardization. So you can just, if the scales are different, here there is the all 4 variables are measured on a 5-point scale. So there is no need to go for standardized one. But if the scale is different, then you need to click here on the standardize. Then continue. Then click on save. Once you will click here, it will ask you range of solutions. So minimum number of cluster we will give 2, and maximum number of cluster we will give 5. This data set is having around 41 respondents. So for 41 respondent, how many cluster solutions you would like to save? So based on that overall similarity measure, you will have a fair amount of idea that whether 2 number of cluster or 3 number of cluster or 4 number of cluster or whatever number of clusters are appropriate. So suppose you have given or you have preferred 3 number of clusters. Then based on these solutions 2, 3, 4 and 5, you will select the 3 clusters, and then you will identify which respondent is representing in which number of cluster. So that is the reason why we are giving multiple number of cluster, right? So in second step, suppose we in the first step only it will be clear the clustering membership, and we will not go for a second kind of the running the analysis. So that is why we are giving minimum number as 2 and maximum number as 5. Sample size is 40, 41. So it is not advisable that you should go beyond 5 number of clusters. So 2 to 5 it is appropriate, and then you can have a continue. If you have larger sample size, you can have a maximum number of 6, 7 kind of a thing. Otherwise 2 to 5 are appropriate. Continue and OK. Everybody is with me? Got the output? Everyone? Fine. So the first thing that we need to observe is average linkage. So in average linkage, the last one, we have 48 respondents. So the last one you need to observe. This 48th one and the last step is one cluster solution, if you remember. And initial one, this one at stage number 1, it is 48 cluster solution. So from 48 cluster solution to 1 cluster solution, this table is being prepared. Now if you observe that for 1 number of cluster, it is 3.84. Then for 2 number of cluster, this is 3.33. Then at 3 number of cluster, it is 3.13. Then 2.97 and 2.70. Can anybody tell me the optimum number of clusters should we go for? How many number of clusters should we form? 1, 2, 3, 4 or 5? Just observe the difference and then take your decision. First of all, did you get this output?
Yes, sir.
Okay. Okay. Dr. Trupti, you are absolutely right. 2 cluster. Karmakar sir, you are saying 3 cluster. So 3 cluster, 1 cluster is 3.84, 2 cluster is 3.33. So the difference is 3.84 minus 3.33. So around 0.5 difference. Then from 3.33 to 3.13. So only 0.17 the difference is, sorry, 0.20. So at 3 number of cluster, the difference is 0.20. At 2 number of cluster, the difference is around 0.5. So this difference is higher. So that is why we will go by 2 number of cluster. So as compared to 1, 2, 3, 4, and 5, the difference is highest for 2 number of cluster. The percentage difference is highest for 2 number of cluster. So that is why our decision will be to go by 2 number of cluster. Is it clear? First choice is 2 cluster. Is it clear, everybody? How can we take decision about the number of clusters? It should be clear. Okay. Okay. So now main work starts from here. Once we identify the number of cluster, then we would like to see that which respondent is representing which cluster, what is the sample size in each cluster, and with respect to demographics, what is the difference in the cluster. So that is what we need to further explore the cluster analysis. So for that, this is again a dendrogram. For that, for the further understanding, you just click on data and split file. Data and split file. Once you will click on data and split file, you need to click here, organize output by groups. Organize output by groups. Then you will observe here some 4 variables or the nominal kind of a variable. It is written here average linkage every time in all variables. So these variables are nothing but you have given a tick mark to solutions that minimum number as 2 and maximum number as 5, right? So one of the variable is for 2 cluster, then 3 cluster, then 4 cluster, and then 5 cluster. So these variables are our saved variables. We need to identify a 2 cluster solution from this variable. So why 2 cluster solution? Because we have taken a decision based on average similarity index. So you just observe then in whichever case average linkage between the variable should show 1_2 kind of a thing. So 1_2 is what? It is the 2 cluster solution. Maybe 1_3 you will observe it is 3 cluster. 1_4 it is 4 cluster, and 1_5 it is 5 cluster. So the variable that you need to transfer here is 1_2. So just transfer that variable into groups based on. Am I being understood, everybody? Which variable you need to transfer? Average linkage between group 1_2. That variable you need to transfer here. Okay. And then just give OK. Dr. Trupti Dave, how many variables you have? Four variables, Trupti madam?
Yes, sir. I got 4 variables, but they are displayed as 2_1.
2_1. Yeah, so 2_1. Okay, fine. You select that one.
Okay, okay. Thank you, sir.
Then the another would be 3_1, 4_1, and 5_1.
Yes, sir. Yes, sir.
Yes. So you select 2_1.
Okay, sir.
Just give OK. So what you have done? You have done a command that your output will be splitted by these two clusters so that your understanding will be better and decision making will also be better. Now, again click on Analyze Descriptive Statistics and Descriptives. Analyze Descriptive Statistics and Descriptives. Once you will click there, just transfer these 4 variables: product quality, website, Salesforce image, and competitive pricing, and click on OK. And click on OK. So you will get this output. Just observe. For cluster number 1, there are 21 variables. Sorry, 21 respondents. For cluster number 2, there are 28 respondents. If you see the average values, then they are having a lower average values. And cluster number 2 is having higher average values. So the product quality for website, Salesforce image, and competitive pricing, the group number 2 has given a highest or higher responses as compared to group number 1.
Excuse me, sir.
Yes.
Sir, in group 1, I'm getting n is equal to 20, and in group 2, I'm getting n is equal to 29.
Everybody is getting 20 and 29?
Yes, sir, even I'm getting.
Yeah, so maybe there can be a slight difference in my output and your file. The file that I have sent, maybe there can be a difference.
Or maybe the version is different of what we are using.
Version will not be a case for the taking differences. Maybe, or you may have selected some different kind of method or distance matrix. There were 2 options available. This my output is being generated by using between group linkage number 1 and Euclidean distance and standardize as none.
Yes, sir.
Maybe you have selected some different cluster method or maybe different interval method. There could be the one of the reason, maybe.
Okay, sir.
So the cluster number 1 is having a lower distance and cluster number 2 lower mean and cluster number 2 is having higher mean. Okay. Moving further, you click on data, split file. And then analyze all cases, do not create group. So original file, again you will get it. Analyze all cases, do not create groups. And just click OK. Now, what we are doing with respect to genders, age, occupation, and cluster, we would like to see the average values of these 4 variables. But we need to check the normality first of all, because the data are parametric obviously, but if it is normally distributed, then only we will go for parametric test. So click on Analyze Descriptive Statistics and Explore. Transfer all 4 variables into dependent list. Click on Plots and give a tick mark to Normality Plot with Test. And just give Continue and OK.
So can you please repeat?
Click on Analyze Descriptive Statistics and Explore. Transfer all our 4 variables. Click on Plots. Give a tick mark to histogram, stem and leaf, and normality plot with test. This is important. Normality plots with tests. And continue and then OK. Can anybody interpret this output, test of normality? Can you tell me whether these variables are normally distributed or not? What do you think? Anyone? Our null hypothesis of test of normality for both these tests, Kolmogorov-Smiron and Shapiro-Wilk, null hypothesis is that data are normally distributed. This is our null hypothesis.
So it is not normally distributed because
yes,
the p-value is less than 0.05, so we reject the null hypothesis.
Yes, as the p-value are, or in all cases it is less than 0.05, we reject the null hypothesis and it can be concluded that these variables are not normally distributed. So we will switch to non-parametric test. Understood, everybody? Okay. So we'll go for non-parametric test. So click on Analyze Non-Parametric Test, and if you have higher version, then go for Legacy dialog. Analyze Non-Parametric Test and then Legacy dialog. If you have higher version, then 17, then Legacy dialog, and then 2 independent sample. If you have 16th version, Analyze Non-Parametric and directly 2 independent sample. So analyze non-parametric test, legacy dialog, and 2 independent samples. Once you will click on 2 independent samples, this dialog box will appear. Transfer all 4 variable into product quality website, all this variable as a test variable list. Grouping variable will be cluster2_1. Click on define groups. Group 1 is 1 and group 2 is 2. Group 1 is 1 and group 2 is 2. Continue and just give OK. There is a by default tick mark of Mann-Whitney U-test. This test is non-parametric equivalent of Mann-Whitney, independent sample t-test.
Sir, can you just repeat previous one?
Okay. Click on Analyze Non-Parametric Test. Higher version greater than 17, then Legacy dialog and 2 independent samples. Transfer all 4 scale variable into test variable list. Transfer average linkage cluster2_1. as grouping variable. Click on define groups. Select group 1 type 1, group 2 as 2, continue and OK. So you will get this output. So what it is saying, whether what you are checking, whether cluster number 1 and cluster number 2, is there a significant difference between these two clusters or not with respect to product quality, website, Salesforce image, and competitive pricing. So just you can observe the p-value. All p-values are less than 0.05. This one, last one, SIG, two-tail. So two-tail p-value, all p-values are less than 0.05. Null hypothesis can be rejected at 5% level of significance. And it can be concluded that with respect to all four variables, there is a significant difference between these two clusters. Okay, understood? Again, moving further, just click on Analyze Descriptive Statistics and cross-tab. Analyze Descriptive Statistics and cross-tab. Once you will click there, transfer all demographic profile as a row variable. And in column, average linkage between 2_1 cluster. 2_1 cluster. Click on statistics. You can tick on row percentage, column percentage, and continue. Row percentage and column percentage. Continue and OK. We are just observing cross tab between our demographic profile and cluster. Should I repeat?
So please repeat the last 2-3 steps.
Okay. Click on Analyze Descriptive Statistics and cross tabs. Once you will click on cross tabs, you need to transfer age, occupation, and gender, our demographic profile variable, into row variable. As a column variable, average linkage between 2_1 cluster. The two cluster solution. Then you need to click on statistics. We require row percentage and column percentage, and continue.
So, can
yeah, please.
So when I'm clicking on the statistics, my version is showing chi-square and correlation. Yeah, this I'm not getting. Observing.
Sorry. You need to click on cells, not the statistics. Cells.
Yes.
And then you will find this one. Row percentage, column percentage, and continue. And then you will just click the OK, so you will get the output. Now let us interpret the output. Cluster number 1 is this column number 1, cluster number 2 is this. Total respondent are 49. With respect to age group, can you observe any pattern that this age category? Dr. Kavita, in statistics, we need not to select anything. Just we are observing the cross tab. We need to click on cells. And in cells, we need to click on row percentage and column percentage. Okay. Can you observe any pattern that which with respect to age category some age categories are higher representation in one group, and some age categories are having fair representation in another group. Do you observe anything? You observe this percentage within age, row percentage. Below 35 age to cluster 1. Below 35 means 18 to 25 and 26 to 35. So cluster number 1 is more representing age group of 18 to 35, and cluster number 2 is more representing age group higher than 35, means 36 to 55. Is it clear?
Yes,
So
sir.
this is your finding number 1. Again, we move further with respect to occupation and cluster. So we can say that businessmen, all 100% are in cluster number 2. So cluster number 2 is of greater than of 35 years of age or 35 to 55 years of age with all businessmen. Whereas cluster number 1 is more of a service category. Though 30% are again in cluster number 2, but here cluster number 1, the service people are 70%. So we can say that businessmen are higher in cluster number 2 and service people are higher in cluster number 1. With respect to gender, can you bifurcate? 40.7, 59.3, 45.5, 54.4. But almost similar kind of a thing. We cannot clearly say that with respect to gender, whether the male respondent are more in cluster 1 or in cluster 2.
Yes.
Right? A slight difference is present. But with respect to other two categories, we can say. So after forming the two clusters, you need to describe the cluster. That cluster number 1 is, what is the composition of your cluster number 1? And what is the composition of your cluster number 2? What is the overall sample size and what is the composition? So this information will be very crucial with respect to further decision making, right? If you wish to target certain people, then because cluster number 2 are giving higher responses, their average value was higher as compared to cluster number 1. So whom you will target? So you will target age group greater than 35 or 35 to 55 and business people. Is it clear, everyone? So in
Yes.
this way, you can just further investigate the clusters. Okay. So this is the cluster analysis. If you have any question, then you can ask.
So can I ask you one question?
Yeah, please.
So can you explain about the standardization? You had explained that in case there are different.
Yes, the standardizing, you just click on that option, standardize, and then see what are the options available. Just I am going back.
Yes, sir.
You just click here, standardize, and then you will observe Z score.
Yes, sir.
You will observe Z score. So select Z score in standardization. Why? When we need to select, when we will have a different kinds of scales. At that time, we will select Z score. So what we are doing, we will the clustering solutions will be generated on standardized score. They will not utilize our row score. Here, the clustering solution is being prepared by using row score, because all variables are having the same kind of the scale. If you are having a different scale, then just give a select in standardized Z score and then continue.
Thank you, sir.
Okay. Okay, fine. Any further question? Fine. So my next class will be of confirmatory factor analysis. Today I have not shared the link of HEMOS, but tomorrow morning I will definitely share it. Right. And then if in installation, if you have any problem, then this is my email address and contact number. You can contact me. So my the next session will be of confirmatory factor analysis. Maybe do you have tomorrow class? Tomorrow, Ravi sir?
Okay, sir. Thank you, sir. And I request the participants, sir, I request the participant to please switch on their videos so that I can take the screenshot. Because I forgot to tell this in the last 3 days, and we have no screenshots with us. So please start your video, please. At least we have some, some pics and memories. Okay, Hitesh sir, thank you so much for today's.
Thank you, sir. Thank you.
And
Thank you,
tomorrow, the tomorrow session will be on.
No, Dhaval sir will be taking, and I think he will take conjoint analysis.
Tomorrow, conjoint analysis.
Yeah.
Okay, sir.
But then also we'll confirm with Dhaval sir. Yesterday we talked, and then he told me that we'll take on conjoint analysis, but then also we'll confirm.
I will talk to him, sir. No problem.
Okay. And then day after tomorrow, I will take confirmatory factor analysis, and on last day, Dhaval sir will take SCM.
Okay, sir. And sir, just send me the link of that MOS.
Yes. Sure. Without fail, I will share it tomorrow morning.
Thank you, sir. Thank you all the participants, and please message me or call. You can call me anytime if any query. Thank you so much. Thank you, sir. Thank you.